Hello, I'm Arthur Lund, and I'm the primary smart contract developer with the Vega Fund. For more information on my background, I encourage you to check our most recent Medium post. Welcome to the first in our series of technical vlogs. We feel the easiest way to show you what we're building is with these demos. Hopefully in the next month or so we'll be able to let the community actually interact directly with our smart contracts. Initial setup is fairly straightforward. Clone the repo. I'm switching into the CLI branch as that's where I added the command line functionality for our initial prototype. I've got this at an accelerated rate since there's a lot to show off. Install all of the dependencies and fire up an instance of TestRPC. Once all of that is run, migrate the contracts onto our TestRPC instance. First, let's take a look at the options we're given. Initially, we're just going to check the balance. It should be the case that account 0 has all of the initial funds. This was before we switched away from a monolithic approach and adopted the use of the Minimi token. The current core contract repository we're developing uses a token factory and is just generally more structurally sound. This initial prototype has been frozen and is mostly meant to show we can put together smart contracts and get them to play nice with each other. We believe our new design approach is worth the additional effort. As you can see, the ability to check and address balance in Vega tokens, as well as transfer value, shows we can implement basic functionality for an ERC20 token. While basic value checking and transfer may seem trivial, we still feel like it's worthwhile to show them in action. At this point, we're going to go through the cycle of initiating an offer through to its execution. We'll also explore how we can interact with the offer through its voting period. The functions we'll focus on in this period are the offer, count, status, and vote functions. Offer is meant to initialize an offer, vote is meant to vote on an offer, count is meant to give the current vote count on that offer, and status is meant to give the pending or finalized status of any offer. In our initial approach, many of the functions of these contracts were set in stone, static. The new design choices we've made with our Alpha Core contracts allows for them to be more modular and upgradable than this previously monolithic approach. As you can see, after we create two offers, we're able to check their status and find that they have not passed yet. In addition, we can see that the count is reflective of the initial votes that we've placed. After checking on the offer's vote status again, we can see that it's possible to vote both for and against any offer. At this point, I'll continue out a couple votes and a couple counts just so that you can see how the system's working, and then we'll go to the execution. In order for the execution to succeed, it's necessary to have a positive vote for the offer that we're looking at. With the approach you're seeing right now, you can see that it's necessary to give the salt that was used in the offer creation. Whether or not that design approach is continued on in the next core contracts is still up in the air, but most likely we'll try and take a different approach with that. As you can see, the execution has allowed the offer to move on into the pass status. This is when we would basically allow the offer to realize any potential value or loss on the network, and then we would go forward to handling CDR. For the CDR, we're just going to show you a very brief example. Basically, this CDR function is a concrete mathematical function. While some of the values in that function are reliant on the structural properties of the Vega token, we think that we can achieve what we need to with the CDR through a library and then possibly some helper functions. That's our presentation. Thank you for watching, and as always, if you have any questions, reach out to either me or George on our Slack.